Oh, hi. Monaco here. This is our Solubility Precipitates Rules Lab, and we're going to be doing some combinations of chemicals, okay? And I need to tell you about the background and the solubility rules, because you're going to have to predict the outcomes of 9 combinations of reactions and decide what you saw, if it was a precipitate or not, using this table F solubility rule. So come on in here and zoom in. Some compounds are soluble in water. That means they'll make an aqueous solution. Others are insoluble. Will make a solid precipitate. Simple enough there. Next item. Table F tells you which combinations of ions make soluble, aqueous solutions and which make insoluble, solid precipitates. Come on, zoom in over here. The way we use table F is we find the ion of interest and to see if it's in the soluble column and if there's any exceptions, okay? So what you need to do is use and find table F to see if the compound we made is soluble or insoluble or soluble. It's kind of like an if-then situation. Logic comes into play here. But you're not going to know how to see which compounds to work with until you come to the double replacement background and some examples. So when we mix solutions, aqueous solutions of ionic compounds, they're going to produce products that have swapped the positive and negative ions. So for example, sodium chloride, salt, table salt, dissolved in water, combined with silver nitrate, a special chemical dissolved in water, is going to make something. And we got to predict what it's going to make. And when we do a double replacement reaction, we take the positive ion from the one compound and combine it with the negative ion from the other. So we're going to get Na and then NO3. All right, boom. And the other part we're going to do, so that was when I combined this and that. When I put those two together, I got that one. All right, and then I'm going to combine it because the other combination has to happen too, Ag and Cl. So I'm going to make some Ag and pink for Cl. So now notice, these were aqueous solutions. So these would look like clear water, clear liquids. These two, we don't know what they're going to be. We can use the solubility rules to figure it out. And in this scenario, when I use the solubility rules, I see that all nitrates are soluble and all sodium-containing compounds are soluble. So I would put the symbol, soluble, not S for soluble. See, it's easy to make a mistake. AQ means dissolved in water, which means soluble. So S doesn't mean soluble in this scenario, it means solid. Then we look at silver chloride. You see chlorine is one of the halides, which makes it soluble unless the first element that comes there is silver. And there's a couple other exceptions. So in this case, we would say that this one is the solid. And in the lab, you're supposed to do the double replacement after you mix the chemicals, then identify which one is the precipitate. So the double replacement and the precipitate is like the analysis part of this lab. The data and the procedures are pretty straightforward. So coming down here to the purpose, you're going to mix aqueous solutions of ionic compounds and observe if a precipitate forms. You're going to identify the precipitates that form from double replacement reactions using table F. Okay. So now I'll show you the procedure. Come on over. No. So what I've got here is I've got aqueous solutions of compounds. Got 6 of them. And when you go 6 by 6 or 3 by 3, there's 9 combinations, okay? And the way you combine these is very important. So I have my setup so that I am going to organize my chemicals in a certain order so that they always make the maximum number of combinations. So there we go. So notice I'm kind of setting these up in what would be considered like a Punnett square, if you remember biology, the traits and the stuff. So what I'm going to do is I'm going to take these first 2, mix them together. Then I'm going to take the first one and the second one, mix it together. Then I'm going to take the first one and the third one, mix it together. So your procedure is taking a micro well plate, taken 5 drops of each chem. 1, 2, 3, 4, 5. Nothing happened. Looks like clear liquid. It's aqueous. It's dissolved. And I'm going to mix it with 5 drops of its combination. And I'm going to see what happens. Did no reaction happen, or did a precipitate form? 1, 2. See that? How it became white and cloudy real quick? That means a precipitate formed. So in my data chart, I would record lead nitrate versus copper sulfate, a precipitate formed. Let me show you how that works on the big chart up here. So your procedure is mix all possible combinations of solutions, 5 drops apiece. Record if there's a precipitate or no reaction. And then at the end, we're going to rinse out and clean up. I want you to know how to have this matrix so that we can test all possible combinations without doubling and tripling. So we're going to basically make a 3 by 3 chart. Okay. 3 columns, 3 rows. And I want you to number them up. 1, 2, do these order, yep, 3, 4, 5, 6, 7, 8, 9. So those are the 9 reactions you're going to do, but you don't have your reactants listed. So we're going to list them up in this order. This is the way that I did it so that we can check your answers on our answer key properly. If you do them a different combination, you might have to swap them around a little bit or look at the answer key a little bit more carefully. PB, lead, nitrate, for then NaOH, sodium hydroxide, then NaNO3, sodium nitrate. Those are the reactants on the left, and the reactants on the right: copper sulfates, copper chloride, and silver nitrate. And remember, PPT equals a precipitate. And then no reaction. Well, actually, nothing happened, right? Nada. Nothing happened. You will want to record if there was a precipitate or no reaction. We know that I just did this first one and we had a precipitate form. So when you're doing on later on in the conclusion, you're going to add this plus that makes, and you're going to do the double swap like I showed you in the background. And you're going to predict what was the identity of that precipitate. That's your purpose. For your CEI, you're going to pick one of these things that made a precipitate, and you're going to tell me about it. This plus that made a precipitate, and I know because I used this, I saw the combination, and I saw table F. So clean up. This is how you clean up over here. You're going to have a microwell plate with 1, 2, 3, 4, 5, 6, 7, 8, 9 reactions, puddles of liquids, some solids in there, some liquids. All you got to do is rinse it down the drain real careful like. Just like that. Rinse it down the drain. Since we're only using 5 drops of each chemical, there's really no need to collect the waste. And grab a towel or a sponge or something and wipe it out. You want the microwells to be nice and clean and clear when you're all done. We don't want any residue in there or any nasty in there. So pretty straightforward lab. I hope this helps you understand how to set it up and carry it out. I'll help you with the one-on-one if you have trouble with your analysis, but that's what I'm here for. Thanks for watching.